Look up at the night sky and what do you see? A vast expanse of stars and galaxies, each one unique and impressive. But have you ever stopped to think about what lies beyond what we can see? We live on a tiny speck in the universe, a planet orbiting a star that is just one of billions in our galaxy. But even our Milky Way is just a small part of the vast universe that surrounds us. So let's take a journey through the cosmos and explore some of the incredible phenomena that exists out there. The Observable Universe. Let's take a closer look at the Observable Universe. This is the part of the universe that we can see, and it's estimated to be around 93 billion light years in diameter. That's an unimaginably large space, but it's just a tiny fraction of what's out there. The Observable Universe hasn't always looked the same. It's been expanding since the Big Bang, which happened around 13.8 billion years ago. In the early universe, matter was distributed more evenly, but as time passed, gravity caused matter to clump together into galaxies and clusters of galaxies. Within the Observable Universe, there are millions of galaxies, each one containing billions of stars. And these galaxies are often found in clusters, groups of dozens or even hundreds of galaxies that are gravitationally bound together. Despite its vastness, the Observable Universe isn't completely random. It has a large-scale structure with clusters and filaments of galaxies separated by vast voids. Studying this structure has allowed us to learn more about the distribution of matter and dark matter in the universe. The Observable Universe is a remarkable and endlessly fascinating place full of beauty, mystery, and wonder. What we can see in the night sky is only a small fraction of what's out there. The Observable Universe is an incredibly vast and mysterious place full of beauty and wonder. But there's more to the universe than meets the eye. Something that makes up a large part of the universe yet remains hidden from us: dark matter. Dark matter is a mysterious substance that makes up about 85% of the matter in the universe. Unlike ordinary matter, it doesn't interact with light, so we can't see it directly. But we know it's there because we can see its gravitational effects on the Observable Universe. One of the ways we can see the effects of dark matter is in the way galaxies rotate. According to the laws of physics, the stars on the edges of a galaxy should move more slowly than those in the center. But observations have shown that the stars at the edges of galaxies move just as fast as those in the center. This can only be explained by the presence of dark matter, which provides the extra gravitational pull needed to keep the stars in their orbits. But dark matter isn't just important for galaxies. It also plays a crucial role in the large-scale structure of the universe. Without dark matter, the Observable Universe would look very different. Galaxies and clusters of galaxies would not have formed, and the universe would be a much emptier place. Despite its importance, dark matter remains one of the biggest mysteries in astrophysics. Scientists are working hard to understand its properties and how it interacts with ordinary matter. They're using a variety of methods, including simulations and experiments, to try to unravel its secrets. One of the ways scientists are trying to detect dark matter is by building detectors that can sense its presence. These detectors are typically located deep underground, shielded from cosmic rays and other forms of interference. Among its many enigmas, dark matter remains one of the most tantalizing. Black holes. These enigmatic objects are the result of the most extreme conditions in the universe, where matter is compressed to unimaginable densities and the laws of physics are pushed to their limits. Black holes form when a massive star runs out of fuel and collapses under its own weight, creating a singularity, a point of infinite density, surrounded by an event horizon, a boundary beyond which nothing can escape, not even light. The gravitational pull of a black hole is so strong that it warps the fabric of space-time around it, creating a gravitational field that sucks in everything around it, including stars, planets, and even light. This is why black holes are often described as dark, as they don't emit any visible light. There are several types of black holes, each with their unique properties. Stellar black holes are the most common type, formed from the collapse of a massive star. Supermassive black holes, on the other hand, are found at the centers of galaxies and can be billions of times more massive than the Sun. The supermassive black hole at the center of our own galaxy, the Milky Way, is called Sagittarius A star. It's around 4 million times more massive than the Sun and is currently in a dormant state, but astronomers believe it may become active again in the future. Black holes may be feared for their destructive power, but they also play an important role in the evolution of galaxies. They can help shape the structure of galaxies by pulling in nearby stars and influencing their orbits. In some cases, black holes can even trigger the formation of new stars. Black holes are fascinating and mysterious objects, and studying them has given us a glimpse into the most extreme conditions in the universe. But there's still so much we don't know about these powerful objects floating in space. Cosmic microwave background radiation. The universe is a vast expanse of mysteries, and one of the most important discoveries about it is the cosmic microwave background radiation, or CMBR. But what is it, and what can it tell us about the universe? The CMBR is a faint glow of radiation that permeates the universe, and it's the oldest light that we can see. It's like a snapshot of the early universe, taken when it was just 380,000 years old, and it's been traveling through space ever since. The CMBR was created during the Big Bang, which happened around 13.8 billion years ago. At that time, the universe was incredibly hot and dense, and photons, particles of light, were constantly colliding with the particles of matter that filled the universe. As the universe expanded and cooled, the photons were able to travel more freely, and they spread out to fill the entire universe. This is what we see today as the CMBR. Scientists studied the CMBR using instruments like the Planck satellite, which was specifically designed to measure the temperature and polarization of the CMBR across the entire sky. One of the most important things that the CMBR tells us is about the distribution of matter in the universe. The temperature fluctuations in the CMBR are caused by variations in the density of matter in the early universe, and studying these fluctuations has allowed us to learn more about the large-scale structure of the universe. But the CMBR has also allowed us to learn more about the properties of the universe itself. For example, it tells us that the universe is flat or very close to flat, and that it's made up of about 5% normal matter, 27% dark matter, and 68% dark energy. The cosmic microwave background radiation is an incredible window into the early universe, and studying it has allowed us to learn more about the formation and evolution of the universe. Neutron stars. Imagine a star so dense that a single teaspoon of its matter would weigh billions of tons. This is a neutron star, one of the most mysterious and fascinating objects in the universe. Neutron stars are formed when a massive star explodes in a supernova. The outer layers of the star are blown away, leaving behind a small, incredibly dense core composed almost entirely of neutrons. Many neutron stars are also pulsars, emitting beams of radiation that can be detected as they rotate. Pulsars are like cosmic lighthouses, sending out a regular signal that can be used to study everything from the structure of the universe to the behavior of matter under extreme conditions. The extreme density of neutron stars creates an incredibly strong gravitational field which can bend light and distort the space around them. This makes them invaluable tools for studying gravity and testing theories like Einstein's theory of general relativity. Neutron stars can also exist in binary systems with other stars, where they can have a dramatic effect on their companions. As material is pulled from the companion star onto the neutron star, it can create intense X-ray emissions that can be studied to learn more about the physics of matter under extreme conditions. Neutron stars are just one example of the incredible and often mysterious objects that exist in our universe. The Great Attractor. As we gaze out at the vast expanse of space, we may think of it as empty and lifeless, but nothing could be further from the truth. In fact, there are countless phenomena and forces at play shaping the universe we know today. One such phenomenon is the Great Attractor. The Great Attractor is a massive region of space that exerts a gravitational force on surrounding galaxies. It's located around 250 million light-years from Earth in the direction of the constellation Centaurus. But the strange thing is, we can't see it. The reason we can't see the Great Attractor is because it's behind the plane of the Milky Way. The stars, gas, and dust in our own galaxy block our view of this mysterious cosmic structure. Despite being invisible, the Great Attractor has a profound impact on the galaxies around it. It's responsible for the movement of galaxies in our local group, including the Milky Way, towards a point in space known as the Shapley Supercluster. The Shapley Supercluster is another massive structure in the universe containing thousands of galaxies, and it's being pulled towards the Great Attractor along with many other nearby galaxy clusters. Scientists are still trying to unravel the mysteries of the Great Attractor, studying its gravitational effects on nearby galaxies and using sophisticated telescopes to try to peer through the dust of our own galaxy to catch a glimpse of this cosmic giant. The age of the universe. The universe is a vast and wondrous place, and one of the most intriguing questions we can ask is how old it is. Determining the age of the universe has been a fascinating and complex scientific pursuit, and the answers we've found have only deepened our understanding of the cosmos. According to our current understanding, the universe began with the Big Bang, a cataclysmic explosion that happened around 13.8 billion years ago. In the early moments of the universe, it was incredibly hot and dense, but as it expanded, it cooled and began to form the first atoms. One of the most important pieces of evidence for the Big Bang is the cosmic microwave background radiation, a faint glow of radiation that permeates the universe. By studying this radiation, astronomers have been able to determine that the universe is around 13.8 billion years old. In the billions of years since the Big Bang, the universe has been a busy and dynamic place. Gravity caused matter to clump together into galaxies, and within those galaxies, stars were born and died, creating the heavy elements that make up everything we see around us. One way astronomers can determine the age of the universe is by studying the oldest objects in it, such as globular clusters. These are groups of stars that formed early in the universe's history, and by measuring the ages of the stars within them, astronomers can estimate the age of the universe itself. Another way we can measure the age of the universe is by studying its expansion. By measuring the rate at which the universe is expanding, we can determine how long it's been since the Big Bang. This method has confirmed that the universe is around 13.8 billion years old. The age of the universe is a mind-boggling concept to wrap our heads around. But through the hard work of countless scientists and astronomers, we've been able to piece together the incredible story of how our universe came to be. Superclusters of Galaxies. We know that the observable universe is vast and full of countless galaxies. But did you know that some galaxies are actually grouped together in massive structures known as superclusters? These superclusters are some of the largest structures in the universe, spanning hundreds of millions of light years across. Superclusters are made up of thousands of galaxies held together by gravity. The Milky Way, for example, is part of the local group, which is itself part of the much larger Virgo supercluster. The Virgo supercluster is one of the closest superclusters to us and contains more than 1,000 galaxies. But it's just one of many superclusters in the observable universe. Superclusters are distributed throughout the observable universe, and studying their distribution has allowed us to learn more about the large-scale structure of the universe. They can also help us understand the distribution of dark matter, which is believed to play a significant role in the formation of superclusters. Superclusters are not just interesting for their size and structure, they also play an important role in the formation and evolution of galaxies. The intense gravitational forces within superclusters can cause galaxies to collide and merge, leading to the formation of new stars and the creation of new galaxies. The study of superclusters is still in its early stages, and there's still much we don't know about them. Gravitational waves. For centuries, we've known that gravity is one of the most fundamental forces in the universe. But it wasn't until recently that we discovered a new way to observe and study it, through gravitational waves. Gravitational waves are ripples in space-time caused by the acceleration of massive objects. They were predicted by Albert Einstein's theory of general relativity in 1915, but it took almost a century to develop the technology to detect them. In 2015, the Laser Interferometer Gravitational Wave Observatory, or LIGO, made the first direct detection of gravitational waves. Since then, several more detections have been made, providing us with new insights into some of the most extreme events in the universe. Gravitational waves are produced by some of the most violent and energetic events in the universe, such as the collision of two black holes or the merger of two neutron stars. Studying these events through their gravitational waves can tell us about the properties of these objects and the nature of gravity itself. Gravitational waves are also helping us to answer some of the biggest questions in physics and astronomy, such as the nature of dark matter and the origin of the universe. During the Big Bang, the universe underwent a period of rapid expansion known as inflation. This produced gravitational waves that should still be detectable today, and several experiments are currently underway to try and detect them. In addition to LIGO, there are other gravitational wave detectors around the world, such as the Virgo detector in Italy and the upcoming LISA mission, which will use a space-based detector to observe gravitational waves in the millihertz range. Gravitational waves have opened up a new window into the universe, allowing us to listen to the sounds of the cosmos and learn more about its inner workings. We've covered a lot of ground today, from dark matter to gravitational waves. But there is one topic that captures the imagination of people all over the world: the search for alien life. For centuries, humans have looked up at the night sky and wondered if we're alone in the universe. And in recent years, we've made incredible strides in our search for life beyond Earth. The Milky Way alone contains billions of stars, and many of them have planets that could potentially support life. And beyond our galaxy, there are billions of other galaxies, each with their own potential for life. One of the organizations at the forefront of the search for alien life is the SETI Institute. They use radio telescopes to listen for signals from other civilizations, hoping to find evidence of intelligent life in the universe. We are also searching for life within our own solar system. The Mars rover has found evidence of water on Mars, and there's a chance that microbial life could exist there or on other moons in our solar system. If we do find evidence of alien life, it could change the course of human history. It would be one of the most profound discoveries of all time, and it would force us to reevaluate our place in the universe. The search for alien life is just a beginning, and who knows what we'll find as we continue to explore the universe. One thing's for sure, the quest for knowledge and understanding will never stop. And there you have it, 10 fascinating facts about the universe. We hope you've enjoyed this video and learned something new about the cosmos. Be sure to subscribe so you can get to know more about what lies beyond our beloved home, Earth.